Welcome to this episode of Mr. Lehman's Knowledge Explosion. In this lesson, we're going to learn how to determine if a quadrilateral is in fact a parallelogram using the coordinates that we are given. If you look at example number 1, I'm given 4 points, A, B, C, and D, and I've plotted them on the coordinate plane, and it looks like a parallelogram, but my job is to verify if it actually is. Now, there are 5 ways we could show that something is a parallelogram. We could say that both pairs of opposite sides are parallel, both pairs of opposite sides are congruent, both pairs of opposite angles are congruent, the consecutive angles are supplementary, or one pair of sides is both parallel and congruent. Now, when I'm working with coordinates, what I consider to be the simplest way is to simply show that both pairs of opposite sides are parallel. Because to show that opposite sides are parallel, I simply need to find the slope. So on this first example, that's exactly how I'm going to do it. I'm going to find the slope of AB, which would be the y minus the y over the x minus the x, which in this case would be 4 minus 3 over 6 minus a negative 2, which is equal to 1 over 8 for the slope of AB. I then go on and do the same thing to find the slope of CD, which would be the y negative 4 minus the other y negative 3 over the x minus the x, which would be 1 minus 9. Make sure you go in the same order, starting at C and then to D for both the y and the x. So I'm going to get a negative 1 over negative 8, which is the same thing as a positive 1 over 8, and you'll notice that these two slopes are the same. So that means these two things are parallel. Now remember, the key word in showing a parallelogram is you have to show that both sets are parallel or both sets are congruent. So you do have to verify that the other two sets of opposite sides are parallel as well. So I need the slope of BC, and I'm going to compare that to the slope of AD. So BC would be the y3 minus the y of negative 4 over the x negative 2 minus the x of 1, which ends up being 7 over negative 3. The slope of AD, that's the opposite side, so that's going to be the y of 4 minus the y of negative 3 over the x of 6 minus the x of 9, which ends up giving me 7 over negative 3. And here again, I've shown that these two slopes are the same, which means they are parallel. I verified using the slopes that AB and CD are parallel, and I verified using slopes that BC and AD are parallel. So I would say yes, this is a parallelogram because my plan worked. Both sets of opposite sides are parallel. That's one way that you could do this. Now, there are other methods. Like I said, I listed all 5 for you. Another way that I often use is I'll show that both pairs of opposite sides are congruent. And this is a nice review of the distance formula and how we go about doing that. For example, if I wanted to find the distance of WX, I could use the distance formula, which says it's the square root of the x minus the x squared plus the y minus the y squared, and the square root goes over all of that. So I'm going to do that for WX. So the coordinates of W would be the x of 1 minus 3 squared plus the y of 2 minus 3 squared. And again, I'm taking the square root of all of that. So it's going to be negative 2 squared plus negative 1 squared square rooted, which is equal to 4 plus 1, all under the square root, which is the square root of 5. So that's the distance or the length of WX. And I'm going to do the same thing for YZ. Now, since this is a smaller picture, I will remind you that you could have, zoom in here on the picture real quick, you could have just counted, we did WX, which we said was square root of 5, and we are comparing that to ZY, which is over 2 and up 1. We could just do a Pythagorean theorem that says 2 squared plus 1 squared equals that zy squared. 4 plus 1 equals zy squared. So we do get 5 equals zy squared, and we get the square root of 5 for this side as well. So these two sides, wx and zy, are congruent. So there's a nice refresher of the distance formula over here. And then also remember you can do a Pythagorean theorem just by counting over and up between the 2 points. So those two sides are congruent, and again, I have to show that both pairs of opposite sides are congruent. So I'm going to go on and find wz and xy in the same way. Now, since it's smaller, I'm going to use the counting method. For wz, it's down 1 and over 2, so that's going to be 1 squared plus 2 squared, square rooted, which is also the square root of 5. And for xy, that's 1 up and 2 over, so that again is going to be 1 squared plus 2 squared, square rooted, which is the square root of 5. So remember the plan. The plan was to show that both sets of opposite sides are congruent. So again, if I zoom in on the picture here for you, what we showed was that wx and zy are both root 5 or congruent, and we showed that xy and wz are also congruent. The fact that they all come out to be the square root of 5 is very unique and would make this a rhombus, because the definition of a rhombus, as you're going to learn, is a parallelogram, which we proved, that has all 4 sides the same length. And that's how you're going to use these coordinates to determine if it is or is not a parallelogram. So here's 2 examples of quadrilaterals where you would say yes, they are in fact parallelograms. Try the practice example and the ones in your workbook and see me if you have any questions.